today I'm going to introduce the sports drinks unit, and I'm going to talk about the dissolving process a little bit. So to get started here, just an introduction to the unit, introductory activity, just thinking about some questions that we might want to answer. What do you think are the benefits of drinking a sports drink while exercising rather than plain water? And we've talked a little bit about that in biology before. And then the second one is, how are your ideas influenced by the marketing strategies of the companies that sell these drinks? And why do they put the ingredients in there that they put in? And hopefully we'll see that by the time we're done with this unit. So here are some of the topics we'll talk about. I'm going to skip over that pretty quickly. And we get to the concept map for the unit. And so some of the key terms we're going to use is electrolyte. Solutions is where I'm going to start with today. Solubility is something we're going to work on in the lab a lot. We're going to revisit the pH system. And we're going to look at concentrations of liquids, which is probably some of the harder parts of chemistry, is determining molarity of solutions, which we'll get to starting today. So here's the first section on solutions and electrolytes. So you've heard the term electrolyte before many times, I'm sure, and we're going to try to figure out what does that mean, what exactly are those, and how do they work. So before we do that, we're going to talk about dissolving substances. Substances get dissolved into a liquid in most cases. So water is typically what we're dissolving stuff into. So for example, salt into water. Water is commonly known as a universal solvent. And what that means is a solvent is the majority of the solution. So if you fill up a glass of water and then you pour a little bit of sugar in it, the majority is water, but there's a little minority substance there, and that would be the sugar. Same in the case of salt water. Salt water is mostly water, but it's about 8% salt sometimes 4% salt. So it's a very small percentage. We're going to talk about what those percentages mean later. So same thing with Kool-Aid here at the bottom. Now, the actual dissolving process is how it works. Last unit we looked at polarity of molecules. So water is polar. It has a negative and positive end. Ionic compounds have a positive and a negative portion to it. And so those are naturally attracted to the water molecules. Notice the positive end of the water here is attracted to the negative end of the ionic substance. So this could be salt, for example. In salt, we would have Cl, chlorine minus, and sodium, Na+. So the water molecules actually grab onto those, and they start pulling it apart, and they carry it off into the solution. And so that's what you see when you pour salt into water, as an example. And there's many salts. Calcium chloride, we'll use potassium nitrate, different salts like that. So these are for ionic compounds. Keep that in mind. The next slide, these are just continuing to pull these off. We go to the next one, we're going to talk about covalent compounds. So these electrolytes, on this previous slide here, these are the electrolytes right here and here and here. If you've ever looked at a Gatorade bottle, they probably have something like that on there, a positive, sodium positive or potassium positive. So those are the free-floating charges in a solution. Anything that produces free-floating charges is called an electrolyte. So salt water is actually technically an electrolyte. Now when we go to something like sugar, sugar is a substance, it's still polar, it still has some oxygens in it, so it's going to have a little electronegativity difference. So the same thing happens. We have positive ends of water molecules down here attracted to this negative end, and the negative end of water molecules here attracted to this positive end. So there's some interaction here, and then there's some interaction between these guys here. And so eventually that water molecule carries off the covalent compounds from the rest of it. So when you first pour sugar into a glass, it doesn't instantly dissolve. It actually sits at the bottom unless you stir it up. And so by stirring it up, we can take these water molecules and they start to carry off the sugar compounds. So here are some properties and types of electrolytes. There's strong electrolytes, weak electrolytes, and non-electrolytes. So non-electrolytes, the key to this is if it's a covalent compound. The difference between strong and weak it's hard to tell exactly unless you run some different tests on it. But the big difference is all the ions versus a few ions are separated when dissolved in water. Now, when we break up these electrolytes, there's a certain process we need to take. And how this works is, you take potassium nitrate, for example, down here. We're going to break those electrolytes up. So I'm going to draw an arrow up here. The first ion it gets broken up into is K+. The other ion is NO3 negative. And we've looked at these ions for a long time now. You can do the same thing with calcium nitrate. So you'd have Ca2+, but now we have 2 nitrate ions. So that's what this 2 represents here, that there's 2 of them there. That's from our balancing reactions earlier in the year. Here's the rest of the results down here, so you can check yours if you want to go back and try those out on your own. So some misconceptions that people have are here. Sometimes people refer to dissolving as disappearing. It actually doesn't disappear because you can still taste sugar. You can still taste salt in the solution. These are the types of solutions, and this is really important for your activity tomorrow. Unsaturated means that there is more solute that can be dissolved. So this would be a clear, colorless solution. In the case of salt, for example. Once the solution gets saturated, there might be a few little chunks down here at the bottom. Just a couple. Not many. But it's still clear and colorless. Now, when it becomes super saturated, we typically see kind of a pile of stuff at the bottom. So this is probably something like salt, for example, or sugar could work too. Takes a lot more. And the rest of the solution is, it can be clear or sometimes cloudy. And it's usually colorless still, depending on what substance is being dissolved. Some substances obviously will have color to them, blue or green or something, but in the case of salt, for example, probably still be colorless, but it might be like a clear, cloudy looking then. So that's it for this. Look at the next presentation on molarity and weight and volume.